That's Stray's tutoring? Hey guys, welcome to today's video. We'll be going over Charles' Law. This is a part of our series where we're talking about different gas properties and gas laws. We've already spoke about Boyle's law, the gay-lussacs law, and we will eventually lead on to the combined gas laws. So with Charles' law, it is the relationship between volume and temperature while pressure is constant. So if we go over to our right, I have this big heart to really exemplify the love and the relationship that volume and temperature have. Even our guy, I was thinking about gay-lussac, guys. Pause. We have our guy Charles with shades on because he's loving this unique law that really shows the relationship between volume and temperature. And I said before, I have everything written down here. Pressure is constant, and then it is the relationship between volume and temperature. So we have an example here. We have some balloons and a hot air balloon. What does this really mean? So I use these as an example because the functionality of balloons and a hot air balloon is because of the relationship between volume and temperature. So as we increase the temperature, because remember, in this hot air balloon, there is actually like a flame or some type of torch that blows into the balloon, thus expanding it, right? So we have an increase in temperature, and we have an increase in temperature. This also means we have an increase in volume, and vice versa. If there's an increase in volume, that means that there was an increase in temperature. So there's a direct relationship there. And I even have an example or more word form where we have a hot air balloon. The volume of the gas is directly related to the temperature of that gas. So when we heat, or like a burner in a hot air balloon apply heat, the gases expand. So when the air inside the balloon expands, it becomes less dense and provides the lift for the hot air balloon. This is all because of Charles's law. There's an increase in temperature for that balloon. Gases expand, volume increases, and it's able to lift and float. So if you guys ever been on a hot air balloon, tell your parents or tell yourself that, hey, thanks Charles' law. Well, maybe you'll thank your parents for bringing you on, not Charles, but just think about it. Okay, so now we have another example here, more of a visual, where we have this gauge set between 200 to 300 Kelvin, and this gauge set right at 500. And of course, this is the higher temperature. So since this has the higher temperature, we can see that the volume is much greater than the volume here. And that is because of the influences of temperature, okay? So if we go into our next slide, I'm doing a quick refresher here for you guys, where the main influences of gas are the amount, the volume, the pressure, and temperature. But of course, for the sake of this video, we are focused on volume and temperature. And we know that gases, when they hit the walls of containers, they exert something called pressure, okay? And again, they're very dispersed, they're fast, they're moving in this container, in this closed space. But again, for the sake of this video, volume, temperature, and then pressure is what, guys? Yeah, constant. Who got that one right? So if we open up our concept map that I love from Karen C. Timberlake, which is my favorite book, we are right here. We talked about Boyle's law, gay-lussacs, and then we'll be really gunning for getting combined gas laws, okay? If we go over to our last slide, we have an example here, and you guys are complete experts. I don't even have to do this for you guys, so pause the video, try it yourself, and then we'll go over it.
3 hours later.
Can you move along? I'm all out of time cards.
I really hope no one struggled here. Let's get into it. Okay, we're back. So to do this problem, let's read it out. A sample of neon gas has a volume of 5.40 liters and a temperature of 15 degrees Celsius. Find the new volume of the gas after the temperature has increased to 42 Celsius at constant pressure. So the first thing we want to go ahead and do is convert. What should we convert it to? We're going to convert the temperatures to Kelvin. So we know that T1, or the first temperature they provide, is 15 degrees Celsius. So we'll do 15 Celsius plus 273 is 288 Kelvin. And we know that T2, or the second temperature they give us, is 42 degrees Celsius. So that'll be 42 degrees Celsius plus 273. And that gives us 315 Kelvin. And what's the first thing that jumps out to you guys is that comparing our first temperature to our second temperature, it increased. So what does that mean? That means that we know that the temperature increased. So the know is temp increase. And when temperature increases, we know that the volume increases. So we can assume or predict that the volume will increase. As far as our condition 1 and condition 2, what is given? We know our T1, and then we know our V1. We know that our T1, or the first temperature, is 288 Kelvin. And we know that our first volume is 5.40 liters, because that's given right up here. Condition 2, we know that the temperature equals 315 Kelvin. The second volume, though, find the new volume. We don't know what it is yet. So V2 is a mystery to us. So we have everything we need to plug and play. So now let's do that. So let's go ahead and write out Charles' law, which is V1 T1 equals V2 T2. And I highly recommend you guys remembering these equations for every type of word problem you guys will get, so you guys can quickly know which one to use. Is it Boyle's law? Is it Charles' law? Or is it gay-lussacs? So just remember the different relationships and then the equations. So now what we want to do is we're looking for V2. We're looking for the new volume. So what we have to do is actually isolate V2. And we do this by writing out V1 T1. And what we're going to do is we're going to multiply across is what we're going to do, just so we could cancel out or isolate that V2 and cancel the T2. Okay, so we have this here. And again, we want to get V2 by itself, so we have to multiply by T2. So these cancel out. And then what we're left with is V2 equals V1 times T2 over T1. So now we could do our plug and play. So we know V2 equals V1, and our V1 is 540, 5.4 liters times our T2 and T1, and we said that T2 was 315 Kelvin, right? T2, and our T1 is 288. And if we use our trusty calculator, one moment, we will get 591 liters. So we can see that the volume increased. We went from 5.4 liters to 5.91 liters. So the volume increased, thus the temperature increased. But we already knew the volume was going to increase. So if you got something in your problem that was anything less than 5.4 liters, we knew something had went wrong there. So that's how you use Charles's law. I hope you guys enjoyed that example, this video going over Charles' law. Let me know what else you guys need, any videos you guys want me to go over. Leave comments down below. Leave a like, subscribe, comment, do whatever you guys have to do. And I'll see you guys next video. Peace.